Okay, in this video we're going to talk about verifying trig identities again. This is part 3 in a series of videos where I'm just going through the techniques and strategies that I use as I try to verify identities. So there are 8 fundamental identities that you absolutely have to have memorized, otherwise you're going to get nowhere with these. So there's 3 reciprocal, there's 2 ratio, and then there's 3 Pythagorean identities, and those are going to be really important in this video. So those are the ones we're going to focus on. So sine squared plus cosine squared is 1. Tan squared plus 1 is secant squared, and 1 plus cotan squared is cosecant squared. And I've kind of boiled it down to, there's really 9 strategies that I use, but one of them I'm not talking about in these videos, because it's kind of, it's not a very obvious strategy. So I've already talked about options 3 and 4, I've talked about options 5 and 6. In this video I'm going to really focus on multiplying by a clever form of 1. So we need to understand what that really means. So a clever form of 1 is really just something over itself, so I usually refer to that as blah over blah. And most of the clever forms of 1 actually come from the Pythagorean identities. So for example, we have sine squared plus cosine squared is equal to 1. So that's something that's proved, so we can actually rearrange it. So we can say that, for example, sine squared is equal to 1 minus cosine squared. But if that's the case, 1 minus cosine squared is a difference of squares, so I can factor it to get sine squared is 1 minus cosine times 1 plus cosine, or 1 plus cosine times 1 minus cosine, depending on how you want to write it. But I didn't need to solve for sine squared. I could have also gone back to the original and solved for cosine squared, and then factored that, and if I had done that, I would have ended up with cosine squared is 1 plus sine times 1 minus sine. So that gives me 2 pairs of things that I can multiply together, and they kind of change the trig function. So one of them changes from cosines into sines, the other one changes from sines into cosines. So I call those Pythagorean conjugates. And there's actually, each of the Pythagorean identities will give you 2 pairs of Pythagorean conjugates. So we can look at tan squared plus 1 is secant squared. If we solve that in such a way that we get a difference of squares and then factor it, that'll give us each of these. So tan squared is secant minus 1, secant plus 1, and then 1, this one's particularly strange, 1 is equal to secant minus tangent times secant plus tangent, so there should be a plus sign there. We can also look at 1 plus cotan squared is cosecant squared, rearrange that into difference of squares, and we'll get each of these. So cotan squared can be rewritten as cosecant minus 1, cosecant plus 1, and 1, again, can be rewritten into cosecant minus cotan and cosecant plus cotan. So those are all the Pythagorean conjugates, so that's what I refer to them as. And the key thing is you want to be familiar with them. So usually what happens is in a problem you'll see one half, and you have to just remember the other half. So if I see 1 minus cosine, in my mind I instantly think 1 plus cosine would be a good thing to have, and I will multiply the top and the bottom by 1 plus cosine. This will make more sense as we do examples, so we might as well just kind of dive in. So let's say we have cosine over 1 minus sine is equal to secant plus tangent. So in this case, both of them kind of look like Pythagorean conjugates to me. The left side looks way more complicated though, so I'm going to work on that. So I see 1 minus sine, so I'm thinking I should probably multiply the top and the bottom by 1 plus sine. So my work will look like this. So I have the original, and then I'm going to multiply the top and the bottom by 1 plus sine x. So 1 plus sine over 1 plus sine. So that's just equal to 1. So this is going to change the way the whole thing looks, but it's not going to change the value because multiplying by 1 doesn't really change a value. So this will be equal to, if you're multiplying to change what the denominator looks like, don't expand the numerator. So that's kind of like a pro tip for these, because you're just wasting your time. You'll end up having to factor it anyway. So I did not expand the numerator, but the denominator I know multiplies to cosine squared. That's why I memorized all those Pythagorean conjugates. And then this is equal to, so I see I can cancel cosine over cosine squared, and I just say 1 plus sine over cosine. So I have a fraction, I can break it up into 2 fractions. You could probably just jump to the actual final answer at that step if you wanted to, but I'm going to break it up. And then this is reciprocal and a ratio, so I get secant plus tan is equal to, and that's the original right-hand side, so I verified it. So I'm going to put a box. And let's do another example. So here we have tan of x plus cosine over 1 plus sine is equal to secant. So the left-hand side I think is unquestionably more complicated, so that's where I'm going to work. I'd like to have two fractions, so I'm going to use the ratio identity on tangent to get sine over cosine, plus, so here I see 1 plus sign, so I think multiply the top and the bottom by 1 minus sign is probably a good idea, because I know that's going to generate a cosine squared for me. So usually when I look at them, I kind of like have a strategy in mind, and I try to do it, and I hope that it works. And if it works, good. If it doesn't work, I go back to the beginning and just try something different. So this will be equal to, there's nothing I can do with this first fraction yet, but the second part, the whole idea, I wanted to change the denominator, so I'm not going to expand the numerator, so I'm just going to write cosine, and then 1 minus sine. But the denominator is just going to be cosine squared at this point. So I get cosine squared, and then you can see in that right-hand fraction I have cosine over cosine, so those are going to simplify, so that's going to give me, so I have sine over cosine, nothing happens there yet. I could have just left that as tangent, it would have been less writing. But here the cosine canceled with one of the cosines in the denominator. Now I have, they have a common denominator, so I can just combine the numerators, so I'm going to actually kind of maybe skip a step, but it's not really skipping a step. I just did sine plus 1 minus sine is just 1. So I have 1 over cosine, and 1 over cosine is the reciprocal identity for secant. And we verified it. Let's look at one more. So this type of problem confuses a lot of students. So I'm going to show you how I do it. So the left-hand side, 1 minus cosine over 1 plus cosine, is equal to the right-hand side, which is the quantity cosecant minus cotan, all squared. Which seems, I really like identities that don't look like they would be true to begin with, and then you do them and you verify it, because I think that's kind of neat. And this is one where I think that's true. It doesn't look obvious to me. So on the left-hand side, I see 1 plus cosine in the denominator, and on the right-hand side, there is no denominator, so I'm going to try to multiply the top and the bottom of the left by 1 minus cosine. So I got 1 minus cosine over 1 plus cosine, multiplying the top and the bottom by 1 minus cosine. Oh boy. So here we go. I want to change the bottom, so I'm not going to expand the numerator. So in the numerator, I'm just going to end up with the quantity 1 minus cosine, and then squared. And then in the denominator, I have 1 plus cosine, 1 minus cosine. Well, I know that that is equal to sine squared. So if you look at the right-hand side, we have something squared. So what I'm going to do is I'm actually just, on the left-hand side, I currently have a thing squared over a thing squared. I'm going to pull them together and put them all under one square. So I have a giant quantity, 1 minus cosine, all over sine. And then that whole thing is squared. So that's one of the properties of exponents that I can use. Here, I see a fraction. I'm going to break it up. I think you could get away with skipping this step. Depends on your teacher, I guess. So I have 1 minus sine, 1 over sine minus cosine over sine squared. And then 1 over sine is cosecant minus cosine over sine is cotan. And then that's squared. And that is exactly what I was trying to prove that it was equal to. And so we verified it. Alright, so that's how we can use the concept of multiplying by a clever form of 1 to verify identities. I hope you found this helpful, and good luck.